Hi, welcome everyone. Good morning, people attending from US, and good evening, people attending from India. So let's connect quickly with our friends, greet our friends, and we have an excellent session today where Haruni is going to lead into a good direction. So we have Sairam. Hi, Sairam, welcome.
Hey, good morning, Srini, and hello, everyone. Hope you guys are well.
Wonderful. Great to see you, Sairam, here.
Same here.
Welcome, Harish. Harish is back into action. Very dynamic, my colleague in Apple. Always love to collaborate with him. So welcome, Harish. You want to greet our friends?
Hello, Srini. Good morning. Good morning, everyone, and good evening to my Indian friends.
Wonderful. So I have Narayana from India. Hey, Narayana.
Hi, Srini.
Hey, welcome back. You want to greet our friends?
Yeah. Good morning, good evening. Hi, friends. Thank you.
Excellent. Welcome. Hema, we're very excited. Hema is with us. Always had a great discussions at Apple. Highly technical. It's great. We're collaborating on machine learning, which is a very exciting topic in the market. And I'm very confident it's going to offer a great career to everyone who is exploring this. I never got so excited about these trainings. So welcome, Hema, good morning. You want to greet our friends? How are you today?
Thank you, Srini. Good morning. Hello, all. Good morning.
Excellent. Lakshmi from Hyderabad, who worked with us in Apple, did quite good contributions. Interesting, she's also my sister-in-law. Welcome, Lakshmi. She worked in PeopleSoft for more than 10 years. Exploring this, I'm very confident this career is going to be excellent even in India. Lakshmi, welcome. You want to greet our friends?
Hi, Srini. Thanks for your words. Hello, everyone. Hope you are doing good.
Excellent. Welcome. Raja, my family friend who did his master's here. I think he's doing a job of master's and exploring this wonderful career. Hey, Raja, how are you today? You want to greet our friends?
Hi, Srini. I'm doing well. Good morning, everyone. Thank you.
Excellent. Welcome. We have Siva. Always do wonderful things. Hey, Siva, how are you today? You want to greet our friends?
Hi, Srini. Good morning. I'm doing good. Hello, everyone. Good morning.
Welcome. We have Taj. Taj. Hi, Taj. How are you today?
Hello.
You want to greet our friends? Can you give a brief background of yours? I think our friends.
Hi, my name is Taj. I got your reference from Akhil.
Wonderful.
We work for Ford Motor Company on the automation and everything, and he told me there's some I work as a Hadoop developer over here in the Ford.
Wonderful, Taj. Did you work on Spark?
Yeah, we work on Spark. We work on big data. We get all this automation.
Oh, wonderful, wonderful. So you didn't attend yesterday, right?
No, this is my first session, but I got the recording kind of stuff. I was just going through all the recordings.
Oh, wonderful. So if you had seen yesterday's recording, that would help us.
Yeah, I have seen, those are the basics, right? I have done all those basic kind of
stuff. Wonderful. That's great. That's great. So welcome, Taj.
Thank you.
It's great you are here with us.
Thank you. I appreciate it.
Excellent. So here we have a few more guys. VB Chowdhury. VB Chowdhury, welcome. Could you please share a brief background and connect with our friends? You want to greet our friends?
Srini, good morning. I am Basvaya. So I logged in from Facebook.
Welcome, Basvaya. How are you?
Good, sir. What about you?
We're doing great. You want to greet our friends?
Hi, all. I am automation and performance testing engineer in Tech Mahindra. I am from Hyderabad.
Okay, excellent. We have Surya. Surya is coming back to US. Hey, Surya, how are you? Want to greet our friends? Okay. So, very good. Give me a minute. Okay, nice. Let's not. Okay, let's utilize the time more efficiently. So we have Harun, who is going to lead us. Hey, Harun, how are you? And you want to greet our friends? Yeah. Before I hand over to you in a few minutes.
Hi, Srini. Good morning. Yeah, I'm doing good. Excited for another new session and collaborating with old friends and new ones as well. Yeah.
Okay, excellent. I'm pretty sure this it's recording. Everyone. So today's session is Harun is going to give us very good understanding about the next level of Scala. I'll leave it to him how he is going to hand over. So he he will be spending around 1 hour 40 minutes, 45 minutes. Then we'll take a break, 10-15 minutes. Then we'll connect another 30 minutes. So today's session is let's target for 2.5 hour session. So next that 30 minutes, I'll discuss with you few environment setup issues and how we collaborate on Facebook groups. Then few other references so that you can practice this week. So I'll give a sufficient assignment related or stuff so that you can practice in the week before we meet next month. As I mentioned in the previous session, the training is going to be very aggressive, which really help you because we are focusing on a lot of content. I'm very sure that very few people target this content in a given time. So I encourage you to spend time in the weekdays also, so that what you learn here will be consolidated. So that way we can touch a lot of machine learning stuff and give you a good insight about it so that you feel very comfortable. So I encourage again, so stay up to 2.5 hours. So that was the agenda. So we'll also take any other questions and also internally we'll discuss so that, you know, everybody will be in the same page. Okay. If you have any questions, you can keep it after 1 hour 45 minutes, we'll talk. So I'm handing over to Harun. Harun, let me give it to you.
Hey, thanks, Srini.
Do you have control?
Yeah, I think, yes. So you guys can hear me, right?
Yes, sir.
Yeah.
Okay. Okay. Let me share my screen. Srini, I think you should stop your screen sharing.
So let me stop it.
Yeah, okay.
Okay. Harun, do you have control?
Yeah. 1 minute. I'm sharing screen.
Hi, DK, welcome. You want to greet our friends?
Hi guys. Good morning.
Excellent, DK. The agenda is 1 hour 45 minutes. Our friend is going to share Scala stuff and few other. We'll take a break, 10 to 15 minutes. Then another 30 minutes, we'll review our installation. Probably I might have to ask you to share a few things, how you have done. Then we'll fix a few other issues our friends have or any of us have. Okay?
Okay.
Yeah.
Great. We'll also take any other questions after 1 hour 45 minutes after the break. So let Harun continue. Thanks. Go ahead. Just to give you, Harun was my colleague for 4 years in Apple, did a great work. Then last 3.5 years, he has been collaborating with me on big data. Then last 1.5 years, almost 2 years, he is fully into big data hands-on. He is a technical lead in a big company. There's a lot of hands-on and a lot of sharing experience. He gave so many seminars in our classes, and also around three batches. He already associated and assisted us, sharing a lot of insight about programming and many other things. So he's a great resource for us. Okay, welcome.
Yep, thanks, Srini. Welcome, everybody. So continuing from the session yesterday, today we are going to mainly focus on the basics, consolidate. As you can see, what we have started yesterday, Srini has started, it's all, it's like a big painting where things will fall in place, all comes together as a big picture slowly as we unwrap each layer by layer. So parallelly, we are not going sequentially like step by step through an index. So we cover all the topics where and when, how they are required, and finally it all becomes clear as a big picture. So continuing from what is required yesterday, today we'll explore further into the Scala as basics, how Scala is used to write Spark programs or ML programs using Spark libraries. So as we know yesterday that when you write a Spark program, Spark is nothing but a processing engine, a set of libraries that we use to write programs either for big data or for machine learning programs. So the Spark can be actually supported that we can write or access these Spark libraries in 4 languages. One is Scala, Java, Python, and R. Okay, so because Spark is inherently written in Scala, it is more coherent with Scala, and we start with writing programs in Scala and exploring the Spark libraries using Scala as a language. So when we start Scala as a language, it's very close to any of the object-oriented program concept. Either you have written in C++ or Java or PeopleSoft. The same concepts are there in Scala as well, and it also runs on the JVM just like your Java code. But you don't have to know or learn Java to be able to write Scala programs. It's more simple and easier than Java, and it's a functional language, and it's more close to writing Spark programs. So most of the programs you write in Spark using Scala are very precise, very small. In fact, you could write the entire job to get the data, filter, transform, put it back into database in just 5 to 6 lines of the program. We don't have to write thousands and thousands of lines of code in Scala to achieve the same functionality. So you're not able to see my presentation?
No.
Agenda?
On your database
No.
page.
Databricks login page is showing.
Oh, okay. All right.
Okay, share the your desktop, maybe.
Yeah. Desktop. Okay, can you see now?
Yeah. Now we can. Harun, quickly welcome Kiran. Kiran, you want to greet our friends?
Everyone. Hi, Srini.
Okay, excellent. Yeah, Harun, please go ahead.
Okay. So Why I'm stressing on this point is that while some of you who have been part of the journey previously with us, who have gone through few sessions in big data, you can clearly understand how this training goes and how we get things as we go further, how things become clear. But for the ones who are joining new, I wanted to stress more that it's not as complicated as difficult as it seems initially. Slowly, when we unwrap the things, it becomes more simpler and clear. So let's focus on the basics today. We start with the Scala basics, and then we use these to write Spark programs. Okay, so today I will briefly touch upon the introduction to Hadoop, not as much as the Hadoop itself, because I know there are sessions which are on the Hadoop. Just for Hadoop, you have 30 hours of sessions, but we don't need all of that. That is for the Hadoop admins or Hadoop engineers. We just need a file system that we can use in Hadoop, just as one of the data we can access other than your normal file system or databases. You can also access files on Hadoop from Spark. So we just touch upon what is Hadoop and all that, and cluster, and what is a big data ecosystem. Like we have been discussing Spark and Hadoop, and there are other tools, databases, how they all fit in together in a cluster, in an ecosystem. What is an ecosystem, and what are the various tools we have to analyze or implement a big data pipeline or a solution. And then Apache Spark, how things come together using the Apache Spark in the big data ecosystem as a whole, how Spark fits in, and how different all other tools are accessible or live in harmony with Spark when a end-to-end solution is built in. So we will discuss these, touch upon these things very briefly towards the end. Initially, we'll start with Scala as a language, variables, how we write collections and functions in Scala. Okay, so I guess most of you have some sort of background in coding. It's just like even like the PeopleSoft. So it's close to all of that. Okay, Shani. So it's close to all of that. You can just start off with Scala as a language. So as we have discussed a few minutes ago, the Scala is an object-oriented programming language, which is similar. It's an object-oriented which is similar to either Java or your people code, because many of you have come from the PeopleSoft background, including me. So it's close to creating objects, methods, and you have all those inheritance and polymorphism, everything you have in all the object-oriented languages. However, the main thing to understand here is that Scala, you don't use all of those inherent language features, because we are not using Scala as a language here. The intention is not to teach you Scala as a programming language. The intention is only to teach you Scala as much as it's required to write a Spark program. Our focus is on Spark and machine learning, not on Scala. To write a Spark or machine learning, since we have selected Scala as a language because it's close, we explore some of the functions, collections, or whatever language features because we need to use that Scala to write a Spark program. Scala can also be used as a language in itself, but it's different, just to create applications, web applications, or different types of for writing games. So there are different applications for Scala just as a language, just like you do with Java. But the focus is not in that direction here. Here we will only explore how Scala can be used to write a Spark program with respect to either a big data or a machine learning programs. Okay, so with that, let's get into our Databricks, which password. What happened? Just give me a minute. Okay, can you all see my screen now?
Yes, sir.
Okay. Okay, so we have seen this Cloudera IDE notebook. So we are going to use this for now to explore write the Scala programs. Later on, we can move to our own IDE. We can write the programs in either Eclipse or IntelliJ and then package. That's all later when we are comfortable writing Spark programs. So initially, just as a command line to execute the Scala code, we'll use this notebook. So first, any feature, in any language, the first feature we look for is variables. How do we declare variables? Okay. So in Scala, we have two types of variables like we did yesterday. One is val and is var. So val is like value and var is like variable. So by definition, val is immutable so that you cannot change the value once you declare it as a val. But if you declare it as a var variable, then you can overwrite or rewrite the values in the variable that you declare as var. Okay, so there we have only two types of variables here. So val x equal to 10, and then you say println x, and then if you say x is equal to 20, so you don't need a semicolon here. So the first time it needs to create a cluster and attach to it. We will discuss about the clusters later, what it means. Okay, so reassignment to val is not allowed, right? So we'll just take this off and then we run it. So it's 10, right? Suppose if I change this to var, the same, and then I can do this. So the final value 20. So here it is println x, right? So this value is printed as 10. Then we have reassigned it to 20. So the second value is 20. Okay. So it's just how you write val and var. Okay. When you write Spark programs, most of the variables you hold are val. Okay, val is explicitly used unless you are using anything to iterate in a loop and then keep adding some values to it. Some use the collections in loops. That is when you create a var. Otherwise, most of the times you just declare it as val. So when we come to features of Scala, so most important feature is that some of the things that are obvious or not required. Just like putting a semicolon at the end, this is not mandatory. It's okay if you put it, or it's okay even if you don't put it. Okay. So some of the things like this are pretty much obvious, that a line ends, you don't have to put it with a semicolon. Okay. And also declaring the variables. So you don't have to declare this as an int. We know that this is an int, but you don't have to explicitly declare it as an int x, right? So it is auto inferred. If you have an integer or a string, it is auto inferred. And then once it is declared, it is automatically preserved the data type of this variable. So similarly, as you have with any other language, you have your integer, string, float, decimal, all those data types that you can create, declare in Scala. Okay. So just like this, you can have string values. Okay. And you don't need to declare any of this as a string or whatever. Okay. So
Harun, like what about the date variable? How can I declare a date?
So dates in Scala, it uses from the Java SQL date. You can use Java utils date, or you can use Java SQL date. So date formats when you want. So it automatically, because it runs on the JVM, it inherits some of the data types or objects that are created in Java. So Java date default that comes, you can explicitly use that Java util date or Java SQL date. Okay.
Okay.
So you can just declare it as a date, but it is like taken from the Java util date. We will come to that when we write programs, when we need the utils. You can do a lot of, see, these are things at a lowest level. You get it everything on the net. So you don't have to remember or learn all of this, but just know that they are already, everything is there and is supported. How it is supported is the implementation. So it supports all of the Java data types because it is built on top of the Java layers. Okay. Okay. So this is the starting point in the language where you have variables. Okay. So once you have the variables, then you have the variables, you have the data types. Then the next step is about the collections, right? So what is a collection? Yesterday we have seen in the session that collection of elements. It's just a group of elements or multiple elements grouped together is a collection. So in collections, you have several types. In all languages, you have collections. So basically, in Scala, mostly use collections like an array, a set, list, and map. So these are the four important types of collections. Of course, there's a sequence as well. So there's the four important collections that you use in Scala in everyday programming. Set, list, array, and map, four collections. So one important difference in Scala from other languages is that you get two flavors for each of the collections, the entire set of collections, not only just these four. There are some other collections which are already implemented, like your tree set, binary set, and each collection is implemented in tree and index formats. But all of those we don't use much. But each of these collections, all the collections comes in two flavors. One is mutable and one is immutable. Okay, so immutable is like once you create the collection, you cannot change it. Whereas the mutable are the collections where you create and then you can change the values within the collection. Okay, so these are so in Scala by default you get both. But when you write a program, if you just declare a collection or just create a collection, by default it is immutable. You will not be able to change the contents of the collection once you create it. So by default it gives you immutable. But if you want a collection that you want to change it later, the values inside, so you can use you can just import that mutable package and then create a collection from that package. That will give you a mutable collection. Like you get an array, you get a mutable array, you get a list, you get a mutable list, you get a map, you get a mutable map, so on and so forth. So there are two basic sets of collections in each, two flavors for each collection. So if you look at it, so in Scala, these are the basic main collections that we use: the set, array, list, and map. So if we explore this, what is a set? We'll just go through briefly and then we will actually create each of these and explore all of these collections. Set is a collection of unique elements and it is not indexed, which means you just group some elements and create a set. Okay, so there is no sequence, there is no index, which means you cannot access an element in the set at a particular location. Okay, so you can access all the elements in a sequence, but you cannot go to a particular index in a set. And it is also unique. You cannot have duplicate values in a set. Okay, so just like set, an array is also a list and array, or two implementations of sequence. Okay, that's okay. Array is a indexed sequence, which means that you can put elements in an array and then you can access the elements by index. Just like here are array of 1, array of 10. So it can directly fetch you elements from a particular position in the array, which is an index. So it's just like arrays, list is also an ordered collection, and users can also access elements by their integer index in the position in the list. And search. So linear implies that it has a direction, so you don't have to worry about this too much, but just to know that you can split the list into a head and tail. Head means the first element and the tail becomes the entire rest of the elements in the list, and you can split that. So list and array are mostly similar, but the very minor differences, like it's a sequenced in list and it's not in array. When you go to a map is just like a key value pair. So you put elements in the map in the form of a key and a value, and you can access the element by providing the key. Okay, if you give the key, it returns the value that is mapped to that key in the map. Okay, it's not indexed, so you cannot get an element at a particular position in a map. You can only access through a key and value pairs. So you give the key, you get the value. And you can also get all the keys and values from a map in separate collections. Okay, and it can also transform the keys and values within the map. That we will see some feature when we explore more transformations in the Spark or Scala program. So these collections, these are the main ones that we use. We also use them in the when we write the Spark programs in Scala, if you want to create objects. So each of these collections, like yesterday we said, when you create a collection, you can make it parallelize. You can make it a Spark RDD from any of these collections. You create a collection and then using a Spark context like we saw yesterday. So we will also explore that. And then parallelize it, distribute it. So when you say distribute, what is the difference between a collection and a distributed collection or an RDD? So that we will go through towards the end of the session. But just remember that these are the main collections. So let us explore these, how we create each of these collections and how we access the elements from these. So any questions here? Anybody? So any questions on mutable, immutable concept? Okay, so today I will show you the collections, but in future you can explore and we can discuss if required how to use mutable collections as well. Okay. So I have created some collections. We'll use this. So I'm creating an array, which is an integer array. The syntax is just like this: array of, I give some integers. That's it. I don't have to declare it as an array or what is the type of an array. So it will automatically infer as int array. You can also create string arrays as well from this, but we will keep it for this. So we'll create arrays of integers. Similarly, we'll create set, list also for the collections. So set. So in the set, when I'm creating here, if you see, I'm putting in duplicate values 5, 6, 5, 6. These are repeating here. Okay. And the second set, I just have 1, 2, 3, 4, 5. So list is also, let's see, 1, 2, 5, 3, 4. So these are not in order. The list 1, but the list 2 are in order. The sequence. Okay. So you just watch for the features what we have for these collections. So we've created array, set, and list. Similarly, we will create a map as well. So I've created maps for months. So these are just, I'm creating the objects. We will see how to access these objects and get the data. So I've created a month map, and month map 2 is map of. So each one is a key value pair separated by commas. Okay. So this is the key and this is the value, and we just put it with an arrow that join these key and value. So this is the key and this is the value. So this is the first element with key value, second element, so on and so forth. This is how you create a simple map. Okay. Now I just create a list of strings. I've created a list of strings, just fruits. So now let's see how we access. So we can access the elements in two ways. One is using a loop. So we all know that we have loops, right? In all the programming languages, we have loops. A for loop, while loop, do while loop. Okay. Similarly, we can also use a for loop, or there is another method called for each, like what we have discussed yesterday in the program. When we printed out for each element, you can traverse through the collection and you get each element. So let's see how we use a for, right? What do we have? Do we have inset? Okay. So what I'm writing a for loop here. First for, I just create a variable. Okay. Let's say variable is X. Okay. For X, sorry. In what is the collection I want? Let's say I want to print set, integer set. Okay, this is the set, right? This is the loop println x. Okay, so look at this structure. Okay, again, when you look at things how they are simplified in Scala. So this is the for loop. Normally in other programs you declare a variable and then you write assignment and then you write counter, right? So all that is not required here. So it declares a variable x. You don't have to again write the data type. It will automatically initialize to the data type what the collection is. So this is from the int set. So we have integers, so it will automatically initialize into it. And this means traverse through the collection, an arrow means, and put each element into this variable for one iteration. So for each iteration, it takes one element from the collection and populates the value of x. That's as simple as that. Okay. So first, let me just run this. I don't want this. I'll just remove this for now. Okay. So just look at here, set elements. First thing you observe is there is no sequence. Okay. And I have put 2 5s and 2 6, which are not here, the duplicates, right? So they are eliminated here. 5 6 and 5 6. So you get only 1 5 and 1 6 here. Okay. So that is how you access the elements in collection. Now the same thing you can write for any of these collections except for the map though. Okay. Let's see, I want to access with another method for each. Println for each. Let's see. Okay. So this is another way of accessing the elements. Now this looks much simpler than the for loop. Okay. But there are some restrictions, like if you want to do a lot of calculations or some transformations, you can choose either of it. But so for each is a method, an action that will work on the collection and its higher order function. So when we come to functions, we will also touch upon what is a function. One difference to note is that here for the println function, we are passing the variable to print. But here we are passing the println function itself to this for each function. Okay. So internally how it works, for each collection, in the collection, it takes for each element, and for that element, it applies this function. So which is same as this. We will go into details later, but for now, just understand that these are two different ways of accessing the elements in a collection. Okay, so any questions here?
Harun,
Mm-hmm.
so all the sets and the list which you are showing here, all of them are immutable, right? Here?
Yes, yeah, all of them are immutable. By default, you get immutable collections.
Okay, unless you specify them explicitly immutable.
Yeah, explicitly you have to import a package called mutable, and then you create a collection from that package. So then you will get a mutable collection.
Okay, thanks, sir.
You can declare them as VAR here.
you can declare, but even if you declare as var, so there is a difference here. A variable is like, it's only for this. Okay, so you can assign any other value to this, but you cannot change the value in this. Okay, what it means is that if I say this as var, this does not make it mutable, which means that once I have this list, you cannot change the values in this list here. However, what you can do is you can assign this list to this variable. Only the variable that you declared can be modified, not the collection that it is pointing to. You understand?
Yeah.
So if I do var, what I can do at the most is I can say this. Okay.
Right.
So if
But
you
you cannot change the values in the list.
Correct. So the int list is now pointing to these values. It does not mean that this list has changed, just that you are not referring to this in the memory anymore. Now your variable is now pointing to this list, not this list. So there is a small difference in actually modifying the value and then changing the variable to point to another object. Okay.
Okay.
Yeah. So if you, when you get into actual writing more programs, you will be very free with using all of those. But I'll tell you, most of the times in my 1.5 to 2 years of writing these Spark programs, I have used mutable collections, I have used variables, and I have also used val, all three of them. So all the RDDs and Spark objects are by default val. You can't change that. When I wanted to do operations by splitting and joining and date calculations and grouping and all that, that is when I used mutable collections. Create a mutable array and keep adding elements to that as we go through process and that kind of stuff. So that you have to anyways declare it as var. Okay, so that will come when you do more operations when you write a Scala or Spark program. Okay, so for now anyways you are clear with this collections, right? So if I write, the list is also same. You can write println x from the list you will get, or you can say string list dot for each println. Okay, here I think we have not differentiated for list. Okay, so this is using the for loop and this is using for each. Okay, so these are the collections. And let me see how. So that's just getting the elements and printing it. Okay. Now, let's say I want to get from, how do I access from map? Okay. So there's an interesting syntax here. So remember we said for in the syntax here, it gets each element and then puts into this variable, right? Now, when you go to map, the element has two parts to it. One is key and is value, right? So when you access each element, so the element is in two values. So you can provide two variables and Scala will automatically put the corresponding values into the two variables. So when I give it in brackets two values, it's called a tuple. What is a tuple? That's unique concept in Scala that we will explore. It's very important. It's called a tuple. But for now, just take it that if I want to group two variables and put it in parentheses as a group, I can give two variables, and from the collection, it will automatically put the key in the first variable and value in the second variable. Okay. There is another way of accessing it, but I don't want to go to that right now, because if I say like for month and month map, I would still get the key value pair, but both of them will be in the same variable. So you have to access it a little different than here. So that we will touch upon later. So I don't want to get too many concepts in one go. So we'll take it step by step. So for now, just say that we give it two variables to the collection, and the collection will put the key and value pairs in the corresponding variables here, month name and month number, and just will print it. So here, month name, March, month number, name. So this is how it is prints both the values from the collection. So the key and value pair, it is easy to access the key and value in one go. Okay. So in the next class, we will explore tuples and case classes, how they are used. The next step that we will take in our next classes. But for now, so this is how you access the collections in the for loop using a for loop or a for each function. Okay, any questions here? So what are the different operations that we can do on these collections, right? So operations in the sense you can get print, or you can get create new collections from these using some operators. So if I say val new list equal to, so I have this list, right? String list. Plus I can give more elements here. Oh, I think it takes a list of. What happened? Where's this? Okay, we'll look into this. I don't know, somehow some issue with this. Okay, I think that list has some issues. We'll check that. But the concept is that if you have a set, plus you can add more elements to it and create a new set. Okay, so it's not list, it's actually a set. Okay, so but inherently these are immutable. This int set is not changing, but you are adding it and creating a new set with more added elements. You cannot add the elements to this set itself because it is immutable. Okay, so that's the concept of the immutable collections here. So how these collections, how they can be used with functions, that also we will explore. But for now, for these collections, you have any questions? You can invoke the higher order functions or the Scala functions on each of these collections for like map, you know, the transformation functions that we use in Spark as well. So that comes from the underlying Scala functions. So we can use map and filter on these collections as well. Okay, so that we will explore as we go into the functions. But for now, you guys are clear with this concept of collections, different types.
Yes, sir.
Right. Lakshmi, you there?
Yes.
Everybody's okay. So just give me a minute. Okay, Surya.
Yeah, I'm good, Harun.
Okay, so you guys are clear, right? Yeah, sorry, who's that? Hello?
Yeah, Harun, I'm good.
Okay, that's fine. So that's about creating the collections and using them for that. So we will let's see what are the functions. Some of the functions yesterday in the Spark you have seen a map function, which is basically a transformation, right? So similarly, you can also have functions. You can from within the Scala to use transformation. Okay, but before that, for any language, we'll see how you write functions in other languages. You also write functions in Scala as well. But in Scala, functions are little more mature or advanced, in the sense you get all the basic function of, for any function you have a name, the parameters that you pass, and the return value that comes out, variables, and the function body, what operations you want to do in the function and all that. Apart from that, there are some concepts like the partial functions, inline functions, and higher order functions. So the different types of functions that you get in Scala, but those are a little more advanced or more functionality on top of the standard functions that we have. So that we will explore. But for now, we'll first start with writing a basic function. Okay. And what is required in Scala to write a function. So what I will do, I will remove all of these print statements for now, or maybe, yeah, let me remove that. I don't need all of this. Okay. So what does a function have in Scala? It is first a keyword which we use to define a function. Def means we are defining a function. Then the function name, a list of parameters, and colon return type. What is it returning, and equal to. Then comes the function body. Return again. So one of the features of Scala is that you don't have to return anything explicitly. The last calculated value within the function is automatically returned. That's another, as we discussed a few minutes ago, that some of the obvious things are eliminated in Scala, or made easier in Scala, which are obvious, right? Like semicolons. So here also in the function, the return values are optional, which means even if you write a return, it's okay. It doesn't break, or it doesn't throw error. But even if you don't write a return statement, also it's okay. The last calculated value in the function is returned by default. Okay. So let's say I'm writing a function to add two variables. Okay. So def add int. Okay. And I have to write the input parameters a colon int, b colon int. Okay. Now return value is int, right? So when I add two integers, equal to So how do we do generally in any language? We declare val c equal to a plus b, and we write return c, right? So this is the standard in any of the languages. Or you also put val c colon int, right? Or variable declaration. So in Scala, this is not required. Okay. Since the return is not required explicitly, all you can do is remove this. And I don't need to store it in another variable, remove this. So that's it. The function body says just a plus b, that's it. That's what it's doing. So by default, it will automatically return the value. Okay, so now what I will do, I will call the function. So I need a variable to store the function, that is return val c equal to add int, say 3, 4. Okay.
So it doesn't matter whether the function is below the you call.
It doesn't matter. It compiles. It does the full compilation. The notebook. So here is a value, return value 7. Okay. Now, if I don't do this, it will throw an error because I am not returning any value. It requires an int. If I'm not doing anything inside and not returning the proper value, you will get a syntax error that it is not returning. And if you don't want to return any value, then you can declare here instead of int, you can say unit. So unit is like your null value in other languages, which means that unit means the function is not returning anything. In that case, it will not return anything, and you can just print from here if you want. Okay, so this is also good if you want to do that, but generally you will return values from function. So you can do this and you can do this. Just write a plus b. Okay, so this is how you define an function. Okay, now in Scala you can also have predefined values for some default values for some of the variables. Okay, so let me first write a return function using a tuple value. Okay, so def string length comma a colon string colon let's say okay. So what I'm doing here is val len equal to a dot length, and now I'm returning a comma len. So I will call val return value equal to a string len of orange. Okay, now see here also I can write let's see, I think this should be okay. Okay, let me check. Oh, this one. It's okay. So let me first check the syntax. It's okay, you get some issues, but yeah, I think this is okay. Now, look at this function, what this is doing. So I'm defining a string length function. I'm passing a string. So the return value is not just, normally we know that functions can only return one value. Okay. But here we can return two values or more than two values from a function as long as we club them into one object. It's like it's returning an object with multiple values, but it's we have grouped it in a parenthesis, just like the first value is a string, second value is an integer. So again, as I told you, this is a tuple, right? Now inside what I did, I took the length, and then here I'm returning in the same syntax. The first one is the string, the second one is the integer, the tuple, and when I return it, I'm storing it in this variable. So this variable has now both the values of the tuple, right? So how do I access these two values? So the first value, which is the original string, can be accessed using this notation, return value. So we know that it has two values, right? So the first value can be accessed using ._1. Okay. And the second value can be similarly return value ._2. So this is length of the string. Okay. So this is how you access the elements in a tuple. Okay, so here original string orange, length is 6. Got it? I think this should also work. I'm not sure why. Let me see. Yeah. So if you see here, you can also directly capture the return values into corresponding tuples. So the A will go directly into str and the len will directly go into this variable, length of the str. So if you print those values, you should actually get the same values here. Okay. So these are the language basics. Generally, how there are subtle differences or improvements, that things that have been made simple in Scala from other programming languages, but the underlying concepts are all same. How you create a function, or how you access call a function, and then how you create all these collections. Okay, and you can also pass the collections as well into the functions. Right now, if I have a collection, so we also know that the map, filter, all of these are also the functions. So how do we use these functions in the collections? Okay, now we say, let's say we have an array, right? Which array? We have integer array, int array here. Okay, now I'm declaring val int square equal to int array dot map okay. Now what I'm doing here, how does this function or this work?
What does map do?
Yeah, I'm coming to it. I'm coming to it. Just give me a minute. First, let us just run this. Okay. So it's square of the integers. Now, what does the map do? Map is actually a higher order function. So I said, like in Scala, you have different types of functions, right? One is a standard normal function you call with, and then there are inline functions and higher order functions, right? So map is a higher order function which actually takes another function, okay? And what it does with that function, let's see here. So what is map? What did we write here in this with this rocket syntax? What we are trying to tell this map function is take each element from this int array, okay? Each element as in the iteration in the loop, and that is assigned to x that we know, right? And for each of the element, apply this function. What is this function? X into x, that is x square, and then put it back in the collection. So that's what it is doing. Now for int array, take each element 1, 2, 3, 4, 5 and map it to this. Map it to what? Map each element to this function. That is, take 1x and map, which means that convert or transform into x square. So that's what we are doing with the syntax. So take each element, square it, put it back in the collection. So now this is a correction. So now we said int array is actually a immutable object. You cannot change it. So int array will still be the original array here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now when you do a transformation, when you map is called a transformation, it will always return you a new collection if you are running on a collection. So the original collection will remain unchanged. It is as it is. So when you do a map, it does all the operations or iterations on the collection, each element, and it will return a new collection with those elements, which is our int square. So that's why when we print this, you get. But if you want to check the original collection, it will still be there. Original collection, then let's say int array dot for each println. See this, you still have the original collection here, and this is your transformation, correct? Transformed collection. Okay. Everybody got this? Any questions? Because I'm going to the next step on this, explaining how an higher order function actually works. Guys, got it? Just give me a minute. Okay, yeah, I'm back. Guys, any questions on this? Everybody clear?
I'm good.
I'm good, sir.
Okay, okay. You guys, I am checking more with the new batch here.
Good, good.
Okay. Lakshmi, you good?
Good, Harun.
Okay.
Thanks for the news.
Yeah. Okay. So just give me a minute. So who else is new on this batch? I think Hema, you good?
Yeah, Harun, we are good.
Yeah, Taj. Okay, yeah, you're good. Raja.
Yes, sir. I was new actually, but I was able to follow. Yeah.
Okay. All right.
I'm
Good.
good, Harun.
Okay. Good. So now in the map function, when we said, right? So this, I said, when I said higher order function, I said that a function which takes another function as a parameter is a higher order function. But here I am not giving it any function. Am I providing any function here?
No.
No. But then how is it working? How is it said higher order function? So there are two other concepts I told you apart from higher order function. That is a inline function. So I'll come to the inline function later, but for the higher order function first. So what is this equivalent to? So let's say I create a new function, def square def square a int colon int okay. So I've created a function called square which takes an integer and then squares it and returns. Simple. Okay. Now I'm not going to do it this way, higher order function. In fact, what I will do is I'll still use the same map. Still map, but what instead I will do is now, as per the actual higher order function, I will pass the function here. Okay, so now this is a perfect description or what it means, right? A higher order function taking a function as the parameter, right? So I'm just passing this function. Now let's see what results we get. Because I'm not calling the function with any variable here. See, we still got the same. So what it does, as we said, right, the map function will take each element in the array and apply the function, this square function. How is it doing if we go back to this syntax? So let's say this is still same. We are explicitly saying take each element and then pass that element to this function square. So we still get the same result.
Yeah.
Okay. So what this means, for each x, take and pass that element to the function, get the return value, and then put it back in a collection and return that and collection into this. That's all steps that are involved in the simple transformation. Now, because we said that Scala inherently simplifies everything, what we do here, even if we don't do this. No, not this. So if I just pass the square function, it is also Same, like for each x, it will automatically take x and apply the square function on that x, that element, each element, because the element is integer and square is also taking one integer. Okay, got this? The higher order function.
Yeah.
Okay. Now that we have known that what is a higher order function, because see, most of the times we use this map function while we are doing our Spark. For all the RDDs, we will automatically use map to transform the data from one to other. So here I simply put x and x square as a transformation. But when you do a map, you can write any transformation either in a function and then pass that function here, or you can actually write the same transformation here. So if I don't use a function, how is this working? Right? So which means that the variables, this what we are writing here is actually a function in itself. This is the function body we are writing. Okay. See here, this is the body, right? A into A. This is same as here, x into x. This is the function body we are actually writing within the parameter. So it means that you can define a function actually in the transformation where you have to pass the function. You can actually write the function itself there. Okay, but we don't have to write a variable, the data types. Okay, what is coming in, what is going out. So it is automatically inferred here. Here, because we are defining a function, so we are writing what is coming in, what is returned. But here we don't have to write that. And we also have not named the function because we are defining and calling the function in the same place, right? So it's not available outside to call anywhere. It is within, the scope is within these brackets, right? So what is written here will be only visible here, right? It is not visible outside, correct? The scope?
Yes.
Okay, so I don't need to name it, the function here. So which is a anonymous function. There is no name for this function. That is why it is called an anonymous function. So we are actually writing an anonymous function here, which is same as this, because it does not have a name. It is called anonymous function. And we are writing the body. And it is inline. We are writing in the same line where we are calling the function, we are defining the function. So it is also called as inline function. And both are more or less used in the same way or meaning, both inline and anonymous function. So here you are defining an anonymous function and calling it, and that anonymous function is what is given to this map as a higher order function. So the square is a function that map takes, so it is a higher order function. So we are passing function here. Here also we are passing a function, but here what we are doing is we are passing it anonymously. We are defining the function there itself and calling it there itself. So that is the concept. Now you guys are clear? Higher order function, anonymous or inline function here?
Yes, Harun.
Okay. So this is a very important concept. It's specific to Scala because mostly for any interviews you go, if you put Scala, these questions will definitely be asked. What is a higher order function? What is a anonymous function, inline function? What is a partial function? So partial function is also there. We'll discuss that later. But for now, this is good enough. Higher order. Yeah.
Anonymous. I mean, anonymous and inline function are same.
Yeah.
Even I have the same question.
Yeah, anonymous or inline functions are same. because
Okay.
you are doing it at the same place. You're defining and calling. Okay.
Okay. Okay.
Harun, if you allow me, I just want to comment.
Yeah.
Everyone, yeah, these functions are very important. But first, focus on level 1 knowledge. What I mean is focus on basics. As you see, the spirit behind why an anonymous function is really designed in the functional programming. So that is a little bit edge towards programming, but I want you to make sure you balance between programming and big data machine learning stuff. Because even in the market, the expectation is you have a good understanding how to leverage the Spark and have a decent knowledge about Scala. But if you're going for a pure Scala program, yeah, then they definitely drill you. So I want you to go step by step without getting overwhelmed, especially when you see the words. See it as a function only. But anonymous functions, yes, there is a reason why they are designed. As we discuss, and usually the way we discuss is we discuss 101, means level 1 knowledge in the Scala for a few weeks. Then we leverage the Spark. Then after you get more comfortable, then we'll have another session where separately, what is the spirit of functional programming, of general functional programming concepts, then how Scala fits into this, all those things. So, okay, I just want to give a comment that, so that people who are a little bit new to functional programming are these about who talks rather, where we talk about a lot of functions, not to get overwhelmed.
Yeah. Thanks, Shin. So that's what I was saying. So don't get worried too much about what these functions are, but it's just that how we are using it. Just we are using it here. We are already doing all of that. You just have to know the names, or whatever the names are. It's okay. But the only thing is that we are using the transformations and writing the transformation here itself as a function. So there's two ways. Either you can write a function differently for the transformation and call it here like this, or you can write the transformation here itself. So you can also do a multi-line transformation here. If you
can also pass that X into the function. See, that is a syntactic sugar. Map square is a syntactic sugar. But if you see map X bracket, pass into the function square.
Here, right?
After the map and that square.
Like this?
No, X bracket, square X. After map, X bracket, square X. Yeah,
that we did already.
You did that.
Oh, thank you. Yeah, it's a syntactic sugar. Actually, in Scala, another thing is the same thing can be written in different way. So here and there in books, you will see they will show for the same thing lot of multiple things. At least the way I learned is 4 years back. I didn't learn all the syntactic sugar. Hey, I want to do this one. Can I able to achieve that? Then after you gain confidence on it, you can focus on different syntactic sugars. Thank you.
So these are different ways of writing. So don't get confused, but there are too many, everything does the same basically. So once you start getting comfortable, you can use any of these syntaxes. Right. So if you have multiple lines, you can, so just as I said, like this is just a function body. You can do any declarations here, val original int equal to X. Then you can say val sqr int equal to X int, and then you can say sqrint here. So this is what you are returning. It's the same thing as x square. So all these, what I'm showing is you can do a lot more. You can do whatever you want to write in a body of a function, you can write here itself. If you put this flower brackets, you can write a multiple lines in the same transformation, whatever transformation you want to use here. Okay.
Okay.
Okay. So that is about the transformation map function. Let me see what other functions we can do now. Okay. We did functions here, return. So let's see how we define a partial function, which means that, you know, the function, we can also give a predefined values when we are defining a function. Okay. So this is a different default sum function I've created, ABC. And here I'm giving default values for these. So A is 5, B is 10, C is 15, and then return ABC. Okay. So here I have three variables that I have to pass to this default sum. Okay. Let's say default sum. Now I'm calling val and sum equal to, I'm calling default sum function. So I have to pass three values, right? A, B, and C. So if I don't pass any values, it will automatically take the default values from the function. Oh, sorry, I didn't print the value right. So 30, right? Default sum is 30, which means if I don't pass anything, it will automatically take the default values for all the three variables, 5, 10, 15 plus 15, 30. Then I can also choose to provide values for some of the variables. So if I say, let me use here on default sum, say 20. I'm passing say 20, 30, 40, three values. Now it will override the default values and take the values we have provided. So the default sum now is 90 because we passed some of the variables values. Let me comment out these for a while. Or I can choose to provide only two values or one value. So when I send 2, it will automatically override the first two variables, and the third variable it will take default. Okay, but you cannot choose to provide the first value and third value. That is not possible. Whatever you provide, the values will be taken in sequence of the definition, 20, 30, and then it will take 15 because you are not provided the third value. It will take as default. Okay, 20, 30, 50 plus 15 is 65. Okay, so these are these called partially implemented functions. So you have already implemented partial value here. And then there are some advanced features I don't want to touch now. Maybe later after a few sessions, we'll come back and then we can check more about partial implementations and all that. But for now, it's like you can provide a function with default values, and you can choose to provide either the values, all the values, or some of the values to the function. Okay. So any question on this? Everybody feel comfortable with whatever we have done till now, collections and functions?
Arun, how to use it in real time?
I have not actually come across a situation where I wanted to use this, because most of the times I define a function and I use it. But I think one of the application is when you have defined a function and exposed to others APIs to use your function, right? In such cases, if you don't want to throw errors when there are no values or wrong values have been provided, then if you want to use default values when there is no values provided, in such cases you can use this. But it is very rare. At least I have not used it.
Okay.
Okay, but it is there if you want to use it, kind of.
Okay.
Okay.
Yeah. Thank you.
Okay. All right. So that is about the Scala collections and functions that we have discussed. So we can talk briefly about the architecture. Maybe Srini will take it further, but I just wanted to touch upon the ecosystem here. Okay, so where does it fit all together? Srini will also take more on this later, but just to give a very brief overview, like, we have been starting with multiple things. Yesterday we looked at machine learning algorithms. We started with the algorithm and clustering, what it means. Then we went into Spark, and then we went into Scala, and then collections and all that, right? So where does it all fit in? And most of the times, whenever people hear about big data, most of the time they hear about Hadoop. For many years, big data was synonymous with Hadoop, but it is not so today and going forward. Hadoop is the starting of the big data ecosystem, where initially when it was formed, it had both Hadoop meant that a file system, which is HDFS, and a processing algorithm or a logic called MapReduce. So MapReduce plus Hadoop file system together, here you see MapReduce and file system together was called as Hadoop in the beginning. So most of the data all of the data was put on the Hadoop file system, and then processing was done using the MapReduce algorithm. So the MapReduce was mainly written in Java, and they were using it for a long time. So today, as things have evolved and the data is getting bigger and bigger, and there are a lot more tools and algorithms and programs and tools have come in. So it has evolved into a new Hadoop ecosystem, where Hadoop actually is a part of it, Hadoop file system and MapReduce. So at the base here, we have Hadoop file system, which is nothing but just like your Unix file system, Windows file system, Hadoop also has a file system called HDFS. So whereas on Unix, you store files on one system, HDFS is a file system for multiple systems, for a cluster. You take 10 machines, you connect it all together, make a cluster, and your HDFS is a file system that runs on all these machines. Okay. What does that mean is that if you choose to store a file on a system, generally on your local system, it is stored on your local system. But when you choose to store on a cluster, your file is actually split into multiple pieces, maybe based on the size. It's 128 MB or 254 MB parts. And those parts are stored in multiple systems across the cluster, not on one system. So you might, if a file is split into 10 parts, all 10 parts might be distributed across multiple systems. Maybe you have a 5-system cluster, so each system might get 2 parts of the file to store. And then it will also replicate. So it will also keep a copy of those parts, so that if one of the system goes down, then it can get the same copy from other system. That's at very high level what Hadoop HDFS means. Split the file and store it in multiple systems, and then replicate and keep the copies in case your system fails. So if you look at here, very high level architecture, so it will have these data nodes, nothing but your small machines. Okay, so hard disk of 6 TB, 6 TB, or it can be 500 GB or 1 TB, whatever it is. Very commodity hardware. And it will have one master called name node. So when you put a file, so the file can be distributed into any of these data nodes. And the name node will keep track of the index where each part of the file is stored in any of these data nodes or slave machines. And this is the master machine at high level. And when you request the file back, the name node will get those parts from all of these machines, make it one file and give it back to you. That's what happens in a HDFS file system. Okay, why the cluster? Because the individual machines are cheaper than one big server. And to handle the uncertainty, if a machine goes down because they are commodity hardware, Hadoop always keeps a copy of the file in other systems. So if one system goes, it can always get from other system. And you can choose how many copies you want to put, 2 copies, 3 copies, 5 copies, whatever you want. And going forward, if your data
where is that stored? The backup ones also in data nodes or in the name?
Yeah, in the same data nodes, same. So if you have one part, if you have 3 copies, so the 3 copies will be stored on 3 different machines, not on the same machine. 3 different data nodes. Okay. So if your data is increasing, you can keep on adding your data nodes to the cluster. That is easier. I mean, if it is a one big server, then you have to buy another server or increase your server space. It's costly. But in Hadoop clusters, you can keep adding your hardware machines to the cluster, make more data nodes, and let the master or the name node know that there are new data nodes that are added. So that is the very basic architecture of the Hadoop file system. So if we come back here, so that is what the basic layer is. And then Yarn is okay, just a resource manager that will manage the resources that we can talk about later. And then there is a MapReduce that I told you, which actually does the processing of the data. So originally it was MapReduce and it was in Java and it was very complicated and it can only do batch processing, not the live or stream processing. And it was very slow. Later on, several systems that came in to do the processing. One of them is Apache Spark, which is in the lead now. And also there are other things like Storm here, Apache Storm and Apache Spark. But Spark is much more adapted and faster, what we are using now. And with the Spark, so on HDFS, the Spark can process the files which are there on HDFS. And it can also process other data marts also, apart from HDFS. HDFS is only one source of the data. So what are the other sources? It can access and process data from traditional databases or NoSQL databases like Cassandra, HBase. It has connectors to connect with these HBase or Cassandra or your traditional RDBMS Oracle through JDBC, through to Teradata or different databases. It can connect and process. It can also connect to the data stores like what you call Apache, Solar, Lucene. So these are search engines where you can put the data back from
Arun?
Spark. Yeah.
Let's have a break. Let's use that our diagram. I will discuss with them because
Yeah, sure. Just give me 2 minutes. I'll wrap it up.
The boxes are a little bit realigned. That's the only thing.
Yeah.
But it's fairly good. But if they have that picture so that where what you called the Cassandra comes into the picture and Hive comes into the
search and Cassandra and all that. Yeah.
It will be all will be uniform in their mind.
Yeah. So that's what I just wanted to show, how the Spark sits in the entire ecosystem, and then you have these elements, Spark streaming that we'll be doing, Spark SQL, and the machine learning Spark ML.
Yeah, sure. Yeah.
Ecosystem.
You can wrap it up so that we'll have a break because anyway you have to go, right?
Yeah. So that is the Hadoop ecosystem where the Spark fits. And as I said, like Spark supports 4 languages to write the programs. We are doing Scala to write the Spark programs here. And these are other data stores like Hive. Pig is a scripting language. And so there are multiple vendors that give you multiple ecosystems which have more or less these tools and more different tools. One is the MapR cluster, Cloudera cluster, Databricks. So all these vendors you have, and then Hortonworks. So each of these vendor will give you something, a bundle of all these tools. Okay, and these are all the data sources that Spark can access and process. So that's why I wanted to give the bigger picture of where what we are doing fits in the ecosystem. Okay, any questions before I call it? We have 3 minutes on any of what we have discussed.
What about that bottom one, Kafka, Flume?
So these are like messaging systems. Okay, the Scoop is it's called SQL on Hadoop. So it says you can pull the data from your. This is a small tool where you can use it to pull the data from your traditional RDBMS databases like Oracle or anything, and put it onto the Hadoop file system from Scoop. Kafka and Flume are 2 messaging systems. Streaming. So whenever the data is coming in, it's just like your messaging systems, like you have integration broker in PeopleSoft or RabbitMQ or MQ series. Like similarly, Kafka is also another messaging system. We will also learn about this in our course. This was done by LinkedIn, created by LinkedIn. This Kafka messaging system where Spark has adapters to read messages that are coming from Kafka or to write to Kafka messaging system. Similarly, Flume is also a similar data ingestion tool where the data can be put into sinks where Spark can read and write to this Flume, a similar kind of messaging system. Okay.
Any question, guys? General architecture I'll show you so that you'll understand where this fits, because this is a good diagram, especially 3 years back. But this, everyone is eliminating this MapReduce. Cloudera is retiring next year. So even Pig and Mahout is now totally on Spark. Now they are just surviving. Earlier, that is the only machine learning library. Now they are rewriting everything with the Spark, and it's no more active almost. You know, if you go to Mahout site, they say everything is on Spark. But it is a machine learning libraries on Hadoop earlier. But since it uses a lot of I/O of MapReduce, it's no more active. It is a little bit active.
Which one? Which one no more active?
Mahout. No. I don't say no more active. Activity is very less. They are the original machine learning libraries, but they are now on Spark. But since Spark has its own machine learning libraries, almost I don't think anyone more than 10% uses Mahout.
Yeah, and Pig is also retiring. I think retired Pig scripting.
Good, Harun. Great session. DK, any comments? How do you like Harun's collaboration?
Very good, very insightful. Yeah, nice. Thanks, Arun.
Yep, thanks, DK.
Great.
Thanks, Arun.
Yeah, excellent. Arun, let's take a break. 10 minutes. Let's come back. Then I'll spend with you 20 minutes. Just this ecosystem, a little more touch. And the next 1 week, how we collaborate on Facebook groups and what is the additional resources I'll share. We'll discuss. Let's come back in 10 minutes. Thanks, sir.
Yep, thanks, Srini. Thanks, everybody.
Good job, everyone. Welcome back. Let me see. Friends coming back. I muted everyone. It's 10:11 California time. Let's spend 20 to 30 minutes. Finish few things. Let me quickly check if our friends are back. Sairam Garu, you're on mute. Are you back? Emma?
Yes, Srini.
Okay, wonderful. Harish?
Hey, Shani, yeah, you're back.
Welcome. Okay, DK, can I continue?
Yeah, I'm here.
Okay. Wonderful, guys. Appreciate your collaboration with Harun. It will be very supportive for us. I want you to take step by step into this. Just for a first week, for 2 weeks, there will be a lot of things in your head, so you need to carefully connect. After that, they become your friends. So Arun has shared one slide, ecosystem. I want to see that ecosystem from this perspective, which is unified Lambda architecture. I have 2 slides I want to discuss, this one and another one company called Pearson Educational Company. They implemented this architecture. So I want to share this also. Both are same actually. This is a general logical diagram where even Netflix and Yahoo, Apple, and a lot of companies uses this architecture. Almost 90% of big data.
But this Lambda is by Amazon AWS or?
Oh, that's a good. Actually, that came only recently. That is Amazon Lambda. Lambda is a concept from calculus where it's like a delta. It's almost like a delta. So Amazon Lambda is, is different. That is using the machines. They charge only when you are using it, even though that is idea. Earlier, you take the machines, they charge the machines for these hours. But now, if you are not running some programs, they will not charge much. So that concept. So Amazon Lambda came only a year back. But this is a big data Lambda architecture. It is not based on Amazon DK. Is that okay? Okay. So let me put everyone. So I discussed this in the orientation, but I want to quickly touch this. Please see. So your transactions in your company or anywhere, you can usually, you all know these transactions are connected, rather collected to OLTP systems, online transaction processing systems. OLTP systems are there to automate the business process. In your company, a purchase order or a sales order or a customer buying a point of sales, then what happens? You want to automate the whole thing, how this transaction flow. Harish and my team worked in Apple, and all of you worked in different companies, where all those systems try to automate the business process. During that time, you capture a lot of transactions, you move the state of those transactions, you might push it to another systems by integrating. Again, they might process and acknowledge and bring it back. You'll be dealing with transactions. So in the current world, they call them as events. Events. People are not calling them as transactions because of this one. LinkedIn, you go to Facebook, you add a friend. You go to LinkedIn, you add a connection, or you comment. You comment for somebody's, rather you give a recommendation to someone, or you did some action on there. So those are all events. So even any changes to employee data, financial data, customer data. People are calling them as events. So those events or changes, these OLAP systems collect and store in a separate systems to analyze the transactions or events. So that is where you need to see your data is funneling. Data is funneling. This data can be your OLTP data or other big data sources or external sources or from Twitter or government data or third-party data or even your B2B partners, any changes or any events, anything. If your company wants to statistically analyze, they funnel it to different integration systems. When I say integration, not general OLTP integrations, OLAP integration. Generally, they call it as ETL tools. DK worked in SAP BW and BPC related, where they, DK, you guys collect from the SAP R3 and the ECC, right? You have connectors, different connectors, and create the data, ODS or whatever the data sources that matters. But you pull. So just if you are handling the OLTP data, it's not a big deal. Already systems are established. A lot of data warehousing systems have that ecosystem. But since the data exploded, so companies, the big data ETLs are not scaling up. The current ETLs will continue. Current data warehousing is not going to be replaced with big data. Please note that point. A lot of people think, have an understanding big data is going to replace data warehousing. It's not. It's not just replacing systems. People get used to tons of reports in data warehousing. There they can do a lot of reporting, human reporting, which are needed. But these big data systems are a different ecosystem to handle not only the big data, to feed to other big data systems, to automate certain analytics, to do advanced data analytics. So if you want to scale this data ingestion, if you want to scale the ETLs, so the current ETLs like Informatica, all those things doesn't work. So that is where companies are standardizing the softwares like Kafka. DK, Hema, Harun mentioned Flume. If you are working on Amazon Web Services, they have a service called Kinesis, or your company may be collecting data from Twitter. So these data will be flowing through these softwares. Kafka. You ask me why you need this. You need a scalable data ingestion system. You please note this as a data ingestion platforms. Data ingestion platforms. RabbitMQ, MQ series, there are other things, but they're unable to scale with the current data loads. So that is where the new architectures have come. Kafka is more famous. Flume is in the same lines, but Kafka is the industry standard, where it was developed at LinkedIn. We don't go to the history because when we talk about Kafka, I'll talk. These softwares are highly scalable. That's what you need to understand. Twitter is anyway source. Twitter gives for businesses, they give an access to pull the data. Even for our classes, we can connect and pull the Twitter data. This is a data ingestion. So this data ingestion can be stored into a batch storages, first of all, for batch processing. Batch processing means you store the data and process it. So you may store into Hadoop, of course Hadoop and Hive goes together, or you may store into S3. In some companies, even here, they may use just MongoDB. They may just use Cassandra, depending upon what they use. But high level, I want you to have this logical understanding. think this as a data storage layer. This is a data storage layer. Data storage layer. For example, I gave Hadoop and Hive and S3. Okay, it can be anything. You need to, when you go to a company, you need to interact with the teams and understand your ecosystem. That's very important.
Srini, one question here.
Yeah.
So you're saying that this will be immutable master data, but what about transaction data? If we want to perform machine learning algorithms on transaction data, which has some updates or anything, then will it not be possible in these systems? Or
no, that's a good question, Hema. Just to give you understanding, this master data does not mean the master data we are familiar in OLTP.
Okay.
This is like a customer data, or even sales transactions it can be. So when it comes to
that data continuously,
what is that?
how do we update that data? Like,
yeah, they have the tools. They just append, they just append.
Okay.
So we will talk when we generally discuss how they do it. They generally have tools. It's a simple appends. That's it. Appends. They don't overwrite. That's why it is just appends. They do every truth. Suppose customer is there in multiple places. Customer there in California. Customer is there in Virginia. Customer. Say, Hema, you came to US to California, then you moved to Virginia. So your data won't be updated. It's a timestamp. Okay. Till this date, Hema is there in California. So from then onwards, she is there in Virginia, or she's going to be there at this time. So every truth about the customer or employee or transactions will be flowing from this transaction systems and will be appended. So that is called immutable because these storages want all the data. They don't want to mess up this. So that's why they will be simply appending. So they call it as immutable. So your customer data, your transactions, everything happened in last 10 years or next 10 years, what is happening, every detail of it, if they want, they can collect. Yeah. Okay, then onwards, what do you want to do? And now you play with it. This, don't touch it, don't update this, don't do anything. You just read. This is just for reading. You read it. So read it and compute what you want. Read it and filter what you want. Read it, build whatever the views you want. Read it or do any transformations or any logics or any aggregations, do it. Or you want to create a multiple subsets of immutable data, create it. Hey, this is all customer data. You create a California customers or India customers, different. Then further you do next layer. Whatever, it's all architectural decisions or project design decisions. But this immutable data is the valuable to the company. If you part of the team, you cannot say, oh, we don't have the data. Somewhere we have overwritten, we don't have that history. No, the companies want this historical data because storage is cheap and people are not worried about the storages now. They don't have to store in the disks now. They can just scale up horizontally in either S3 or in Hadoop. Hadoop is a system of software where multiple machines come together. Just like your one server is having a Unix platform. Imagine 100 machines, 100 servers together, 100 Unix boxes or 100 Windows boxes. On top of it, Hadoop is a software which runs on it. Imagine Hadoop like a operating system for those thousands of machines. But anyway, let me not get into details of Hadoop right now because I need to take one step back to see a little bit high level. But Hema's question is very relevant. So this is a immutable data. Companies can store all the data. Now, once you have so imagine this as a data storage. Now, companies want to process that data. For processing, you need a framework. So what framework you need? Can you write a simple Java programs? Can you write simple Python programs? No, because these storages are big data storages. They run on the cluster. Cluster means thousands of machines. So you need a computing software, Emma, you need a computing software which can run on these 1,000 machines. So the parallel program, multi-threaded processes. So the industry has standardized earlier as a MapReduce, which was there last 10 to 12 years, but MapReduce is aged. And even in the industry, there is a talk that, in fact, big data didn't grow so much compared to the buzz it created. It is because of, it is too technical, too low-level programming. So all these low-level programming and slow processes, and they're not suitable to run on the machine learning systems. They're not suitable to, I'm talking about the computing systems, big data computing system. Whenever there is a big data, there is a storage system, computing system. I'm talking about computing. The computing MapReduce doesn't suitable for machine learning. Apache tried to do it using the Apache Mahout. DK, you asked me a question, right? What is Mahout? So Mahout came from actually Hindi word, Mavut. In Telugu, Mavati means if they treat Hadoop as a elephant. So Mahout is like in Telugu they say Mavati. So who controls the elephant? So the machine learning libraries they try to do, but since MapReduce doesn't do iteratively, it has to every time go to disks IO. So that is where it was so slow. In fact, that is the motivation where in UC Berkeley, one PhD student started writing Spark using Scala, where they can use in-memory, where they can do iterative computations without going to doing a multiple IO. That's where it caught up the fire. So anyway, last 4 years, it has become a de facto standards. So as I mentioned, this Scala and Spark became a de facto standard. There are a couple of other products are coming nowadays, like Flink, etc., but don't worry about it. So this is called a cluster computing platform. So Spark is a cluster computing platform. So it is, I call it as a data processing. To process this data, Scala and Spark is used. We use it. So it is Hadoop, still it is Hadoop IO compatible. So any source which is Hadoop IO compatible can be linked to this Spark and Scala. So even some sources, even though they are not Hadoop compatible, in between there will be a connectors. Suppose you want to speak to Cassandra, the data bits itself may not be Hadoop IO. That's why they use a connectors where the Spark and Cassandra connectors will be made as a Hadoop IO compatible. So when you read from these data sources, they come into as a RDDs. Yesterday we have discussed. So in the high level, so this is a data processing layer. So with this data processing, you can handle any master data, any layers. What do you want to do with this? You want to write into Hadoop itself, or you want to write it to a system called Cassandra, system Elasticsearch, for different reasons. What is the motivation behind processing it? Or you want to process it and send it to data warehousing systems so that people can run manual reports. Yes, you can. So your big data system and general data warehouse systems coexist together. Apart from that, there are systems like Cassandra, Elasticsearch, where you write to it for a useful reason, for some functionality your project is designed. You'll slowly understand. Some people might have already imagination why they are used. I even talk in the next slide. but I want to get this sense. This is a data processor. So this whole layer is called batch layer. This is a data ingestion softwares. This is data storage softwares. You need to do a processing, so it is a data processing software. But since this is DK HEMA, since we are storing and processing it, it is called a batch processes. The process may run 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, sometimes even 10 hours. There are data sets in the nuclear research, in the Hadron Collider in Europe. They are using Spark and big data platforms. The process run almost 11 hours, even though they are fast. This is batch. Since you write it to Elasticsearch for a search functionality, you want to write it to Cassandra or MongoDB so that you can build that web services, rather data services, they're called, because they're built on web services, so that your company can do a lookups of certain data instead of doing a lookups into OLTP systems. I'm talking about systems. Instead of calling into OLTP systems for all the data, certain systems which are not mission critical, which can wait 2-3 hours delay data, they can look into these systems using data services. I'll talk about that in the next slide. It's clearly shown, but I just want to highlight this. This is called a serving layer. The serving layer because it can do a lot of services to the company. Okay. Now see, the data can also, some data may be mission critical. Your company want in a real time. So some stream of data, they can flow it to process instead of storing it and processing it. The data can flow as it is injected. You add a friend in Facebook, it can flow through Kafka, and certain systems can process it and can make it available to the users. So this is a stream layer or speed layer they call. The Spark can be used to process this. If you see here, Hema, DK, Sairam, Harish, and everyone, if you see here, you don't store anything here, but still you have to process here. Even for processing, you need a machines. So see this as a logical diagram. So here also you have a cluster. Here this is a storage cluster and processing cluster. Here you don't need a storage cluster. It's a processing clusters. But it's a logical, but the same cluster can be used for processing also. So don't go to details how physically those machines are there. See it as a logical diagram. It's a processing, you need to process this, data will be flowing. But finally, you will be persisting into either Cassandra or some other systems. So in our class, you'll be learning the data store, how you data ingestion, how you store the data, how you process the data, how you connect to the serving layer, how you write it. Also, you do data streaming and how you process this data streaming and write it to serving layer. So batch layer, speed layer, service layer. This is a unified Lambda architecture that different companies are using. I'm going to show next slide. You can reserve your questions for next slide. Same architecture, a company called, which is, I mentioned, Pearson Education Company, they did it. So see here, this is your domain events, any activity data or any events, whatever it is a uniformly getting into one integration system, Kafka software. It is their official publicly shared architecture. So they put the batch layer this side. They just logically shifted Hema. See here, this is the batch. They have a integration software called Camus. Apache has some other software now. Some integrations. You don't worry about it. Here, this is just the connectors. There is no programming is involved. Here also the connectors. So the connector is coming into batch. They use, if you see Hema, DK, Sai,
Yes,
Harish, everyone, they don't use Hadoop. They use Amazon Web Services. Amazon has a service called Elastic MapReduce. It's like a Hadoop. They have a storage mechanism. Of course, in the backend, it uses the S3. So it's a storage layer. See here, storage. They use it for storage. But they need to do a computing, right? For computing, see here, Spark batch jobs. Of course, they have some MapReduce jobs also, which they're rewriting into Spark. So if you see after the processing, Sairam, everyone, see they can be able to write anywhere they want. They can write some relevant needed data. Maybe they are writing to S3. Whatever they wrote, see here, they can run machine learning analytics. So whatever that data that is needed for your machine. See here, they can write the data into Cassandra. So this data, they may be using to build data services. Emma, can you imagine this? Because you came from a lot of web services background.
Right. This is the API layer where it interacts with the database.
Exactly. You are building an API on top of it. So that, see here, all in your company, transactions or some other things, you are looking up, you can look here. Just a great example is weather.com. Weather.com. You go to weather.com, you can access that weather.com through browser, your cell phone, or even some other tools. They access through APIs. But how the data came into weather.com? Imagine weather.com as a backend Cassandra. So this data came to weather from a lot of weather stations. Right, Sairam? What is the temperature in North Carolina? People will be measuring there. They have weather stations there. And what is the temperature? Certain predictions also will be there. Reality data will be there. Those devices will be feeding through IoT devices into this. If there is a delay, they can write it and process it and quickly push it. Sometimes there may be delayed data. Some 15 years back, Yahoo gives quotes, delayed quotes. If it's a real-time data, yeah, this real-time, they can push it to streaming and process it in sub-second. They can write it to Cassandra. Let me see, somebody put a message. Okay, let's see. So they can write it to Cassandra. DK, do you see this? They can also write it to Search or to do some Search functionality. In some companies, the Search and Cassandra or MongoDB can exist together. Search you will do and the content you may pull it. But combinedly, they may build a web services here, this API, so that there can be a weather.com website here. Also, if you want to do advanced computing, certain computings can be done using graph computing, where you want to establish the relations between your partners, or even in Facebook or Twitter, who has how many followers. Facebook uses a Facebook graph. DK connected to Srini, Srini connected to Hema. So then what can be the weight between DK and Hema? So can we, based on that, can we do some suggestions? Can we suggest, Hema, can you connect with DK? Something like that. They get more insights using some graph computing also. There are some graph databases also exist. So I encourage you to understand this so that you'll have a good picture, so that you can understand the ecosystem easily, where different softwares exist, how different projects can be aligned to this architecture, where you'll be writing streaming program, where you'll be writing batch program, where you will be writing machine learning programs. You will have a good understanding. Okay. Does that help, DK? Any question? Please ask me some questions on these two. Emma, Tyram, I know we have discussed this many times. Basava, Taj, you worked in Henry Ford, or rather Ford. You might be knowing this. Surya, Raja, Lakshmi. Emma, any questions on this?
No questions.
DK, does that help you to give insight?
Yeah.
Sairam, any question?
No, Srin, I'm good.
Okay, excellent. So always you refer these two slides. I'll be sharing this. Okay, next. So how we are going to collaborate in the coming week. So first is easy collaboration is I want everyone to connect with me on Facebook. I think a lot of people already connect to me. I'll add to Facebook. This is my Facebook. Please connect with me so that I'll add you into the group. So in that group, I'll be sharing you to the resources, what you need, step by step. I won't dump the resource. We have so much of resources. So I give all those things. You will not attend the class. Not that you will self-learn, not that. You'll be overwhelmed. Actually, there is a lot of confusion in big data world. There are hundreds of tools. People get so much confused. But the industry is gradually moving wonderfully by consolidating with standardized APIs. It is absolutely going great direction. So I will make you comfortable on that. Yeah, Hema, you're asking some question?
I think you're not sharing the screen. It's showing the last slide only.
Yeah, I didn't say anything, actually. Okay. So on Facebook.
It's on the chart.
Yeah, I did just chat. On the chat, I gave my Facebook URL. Please connect with me. Okay, that is one thing. Then installation. Let me exit this way. Give me one second. Okay. So till now you are using Databricks Cloud. In the coming classes, we'll be using Cloudera also. So this is the Cloudera you need to install in your local system. Already, some of you already have installed, where you will have your Unix command, also Scala editor, where we'll be writing these programs. So we'll be introducing those things in the coming class. So I have a installation. I shared it, installation instructions. Some of you have already installed, and I'll be further sharing into Facebook. DK, can you just give a few lines of your insight, what all you have done in this area? Or I can run this.
You mean installation?
Yeah, you done this step, right? Okay, these are
I've done that Databricks Cloud Access. Yeah, I mean, we set it up as a guest user. I mean,
very good.
Set it up, and then it sends you an email to confirm, and then you can log in and have access to the cloud Databricks. So that's easy. That I think I've done.
Right.
Okay. And also, then the next step is to install Oracle VirtualBox.
Very good. You've done this, right?
Yeah, I've done that.
So how did you just downloaded and extracted it?
Yeah, downloaded it. It takes some time depending on your internet connection, but once you download, you extract and then basically click the setup, so it will install the VirtualBox on that. And then you need to basically import the Cloudera appliance, basically. Once you install,
so next step is, DK is saying,
first
go to this site and You register, you download it for VirtualBox because you have installed VirtualBox. You'll be downloading this. This takes a lot of time, right, DK, for downloading?
Yeah, downloading it takes some time, yeah.
It takes time, so extract it. Then what, DK, you done this step, right? You imported the appliance, right?
Yeah.
So you will be going to that and doing an import. Let me close this. Okay. So you open the VirtualBox and import the appliance. DK, you done that, right?
Yes.
Then you get this. You can
You
start.
get that, and then you can double click, it will start.
Right.
Start the Cloudera.
Okay. So this is the VirtualBox, as DK mentioned. So then you will be downloading and importing it. How you will be importing? This is the one, machine file import appliance. Then it will ask you, where is this, your file? That way it will import. After that, you can just start it. It takes some time to start first time. You will be reaching this Cloudera virtual machine. Interesting, this has all the installation, basic Hadoop, 1.6 Spark version, but we can upgrade it to 2.0 after some time. Then it has a Eclipse editor, which you can open, and this is the steps I have given you. This is the unique shell everyone can open, where it puts you into home Cloudera. You can create multiple folders here. Okay. You can play with Hadoop FS. That we will show you in the coming classes. Don't worry. So Eclipse editor, you need to, this is a Java Eclipse editor. You need to make it a Scala compatible. That is where few steps are there. This is some sample data. Get some sample files, sorry. You create a directory, go to the directory. You use this command, the Unix, these sfpd, csv will be, all these, some files I have given, just to get them into your directory.
Yeah,
so,
I've done that.
Yeah, you've done that, okay?
Yeah.
Yeah, okay. So even if you want to download it to your local directory, just take this and copy and paste in your browser. This file will be downloaded even to your local directory. This is one step, might give some trouble. So, but try in this week. So by next weekend, Saturday and Sunday, by that time you need to have it. So follow these instructions. If you have any issues, post on the Facebook. We'll try to support you. Sairam, in the 5. This is, I think you have 5.8 Eclipse, sorry, not Eclipse, this Cloudera, but this is 5.12. Can you also try to download and see? See, this is my 5.8, which you have, I think. But this is 5.12. So it has a small glitch with the Eclipse Scala. So I don't know if they fix it or not. If they fix it, it will go. If you otherwise, it may get some issue. Then see here, I mentioned that also. Scala may have some glitch. Emma, you also please try this. Otherwise, you know, if you find that glitch, just get another plugin and extract it and load into the Eclipse editor. That way, Eclipse will be compatible to Scala. So you have 1 week time, so don't worry. You don't have to do anything next couple of days, at least this step. Or even the whole installation also. The idea is you should get it done by next Sunday. So that following week, you'll be working on this. So this whole week, I encourage you to work on the Databricks. So for Databricks, I just missed one thing for you to where you You need to know, Hema, you need to know how to upload files into it, right? Let me quickly show you. Give me, time is running quick. Give me, time never will be sufficient for us. Always 30 minutes, but it go to 40 minutes. Okay. Everyone, Hema, can you see this?
Yeah.
DK and everyone, please see here. Suppose you have a file. What is the file? I put on the, if you go to, let me show you. Okay. I shared you some YouTube link, that video, yesterday's video. So below that YouTube, in the description, I gave some links. That links have the files we have used. We have used word count. We have used SFPD. I'll also post this on Facebook, this one. Give me 1 second. Even this one, SFPD, this link. Even if you use in the browser, you can download it to local. After you getting into local, you can upload to this cloud. I want to show you how to upload to this cloud. Basavaya, DK, please see this. So here there is a button called data. Emma?
Yes.
When you click this, you
follow.
Who is this? Baswa?
I'm Baswa Srini.
Yeah, can you follow me?
Yeah.
Okay, very good. Okay, you log into this. This is a free account. For that, you click this data. There is a plus button. You see here, tables. Click this. See here, drop files. Don't worry about this. Just browse this. Then you know whatever it is. If you upload it, any file. Let me show you. See here, word count. I have a word count file. I click this. Hema, when you click this, you get the checkbox. Then it will give you the path, Hema. Okay.
How much storage it will give?
I think it will allow some half gig or something, or 1 gig. But most of the file, for the simple practice, it will be 200 MB like that initially. After that, you know, we'll go into our local machines. Also, we can practice on Amazon Web Services also. But start here. This will give path, Hema.
Yeah.
You copy this.
And use it in this path.
Then, okay, you can wherever you want to use. You will use, you know, val data is equal to sc dot text file. I already shared this particular code.
Do we need any special permissions if we are trying to read it from our local disk, from Databricks?
It doesn't need from Databricks. You just upload, right? When you're uploading, it doesn't ask you anything.
No, my question is, why are we uploading it to Databricks? Can't we directly read it from our local machine?
No, because it doesn't have access to your local. This one is on the cloud, right?
Oh.
Whereas if you go here, it will read in the local. Suppose you want to read.
Oh.
There is, I'll show you next class. You can even use Spark Shell here, where you can read from your local. Okay, Hema, we will discuss that. Right. Okay. Here it doesn't talk because this is on cluster on cloud, and that doesn't have a tunnel to your system. So you need to upload to here. So that is where you will be running your code. No. So that code I already shared. I published it. You go to that YouTube video. Below that, you will see those links. Is where you can get the whole code. Did you get what I mean?
Good.
Yeah.
So I didn't get
Yesterday we
what
done some code, right?
right.
Say I have a notebook. This one. Yesterday
Right.
I was General Spark General. So the whole thing I shared to you actually. Like this, I published it. When I published it, I got an URL. You know?
Right.
So this whole code I shared that in the YouTube video below that link I shared. So just like this, you know. Everyone.
In the Facebook page.
Yeah, even in the Facebook, I will post that. Okay, those links. So what I'm saying now, you click this link, DK. You click that, the whole code, whatever I ran. Can you see?
No, I'm just question is where did you share it? That's my question.
I shared
It's in
that under YouTube
It's
video.
in the description box for YouTube video. And the
Okay,
YouTube video, you have a description box.
Okay.
Description
Nice.
box.
Okay.
But how it looks like this looks like this. Basavaya, can you click this link if you can see the code? Taram, can you see?
Yeah.
So whatever I have done, this code, whole code is available to you. So use this Databricks cloud and try to run what I shared today. And I will ask Harun also to share whatever the code he has done on the Facebook. And I'll share some Scala resources to you so that you can practice. This whole week, please do that. Then one more request is before coming to coming class, try to see these videos, these 2 days videos, at least to see once. That's my request. Then you'll be wonderful shape. You'll be going in a good direction. So everyone, I encourage strongly. This field is growing like anything, and you will be really, really excited. Not only to get into this. When you work also, you work with very knowledgeable people and your energy really grows, trust me. And you will have a lot of problem solving capacity, your tools. Right now, a lot of people are working in a software industry. You are in projects and you do different work. Definitely that's a great work. But this is beyond, because you'll be solving really, really valuable problems to your company. So it means you may be putting same effort like what you're working now, but you're adding a lot of value to your company. So they appreciate and your returns will be good. The career path also will be excellent, and you will be appreciating yourself. You look back after 3 years, you will really, really appreciate what I shared to you. You will appreciate yourself for investing your time and money on this. Okay, any questions? Taj? So we'll be doing the another way is organizing is on Saturday we'll be doing more machine learning stuff. On Sunday we'll be doing more supporting technical stuff that is needed for machine learning. So we'll go these machine learning and big data stuff go in parallel. So, but everything has a link. On Saturday we'll be doing machine learning model. Next week we'll be working on anomaly detection modeling. In fact, tomorrow I'll share it to a Facebook post. Next 7 weeks, what we do, a high level planning also, I and Harun did it, so that I'll share it on Facebook. So Taj, you have any questions?
No, I'm good. Thanks. It was a lot of information today. Really appreciated your hope.
Yeah, thank you. Because we want to go at a good pace, because we have a lot of content to do in the next 7 weeks. So we have a lot of content. So we are going a little bit aggressively. Please catch up, but at the same time, if you don't follow, please feel free to reach us. Absolutely, we optimize the speed. I'm pretty sure I'm going to touch the fundamentals. I know the game because I've been doing a lot of trainings for a quite long time. I know how to take, but at the same time, as we do in every week, some repetition will be there, repetition of the fundamentals, where it consolidates your further understanding. Okay. 2 more minutes. So, DK, how we are doing?
Pretty good.
Excellent. Narayana?
I'm good, Srini. I'm good. I'm good.
Sairam, are we doing good? Harish, are you catching up everything? Okay. Hema,
Srini, very good.
you're getting
Yeah.
great insight, definitely. Okay. Kiran, Lakshmi, Raja, Siva, how we are doing?
Pretty good,
Yeah,
Srini.
good streaming.
Doing well.
Basavaya, any comments?
Yeah, very good, Srini. So useful for us.
Excellent. Let's collaborate it, guys. So
Sure.
every week, even I will be spending at least 10 hours learning new things. I even encourage you to learn these new things. Trust me, these are packaged very well, which are very marketable skills. So you don't have to learn 100 things at 100 training centers. No, absolutely everything is packaged here. Okay, here and there, if you're not comfortable in some area, we'll find a way to, it's all we do is collaboration. Maybe Hema can help you, Sairam can help you, Siva can help you. So we optimize the resources also. So feel free and just enjoy and feel great about this learning. Don't think learning is a weakness. Learning is a strength, and the things are changing a lot, but all for good, all for give a good growth and good money for all of us. Okay, guys. Raja, please connect to me on Facebook, not Raja, Taj. Anyway, you are connected to Akil, so I can reach you. Yeah. So we're done. Thank you and have a good rest of the day.
Yeah, thanks, Srini.
Thank you. Thank you.
Thanks very much.
Good night.
Right. So bye. Lakshmi, bye.
Bye.
Harun, bye. Okay, great. Please take care. We'll be looking forward for greater collaboration with you. Surya, bye.